Let's solve a two-step inequality, or let's do two of them actually. Just like if there was an equal mark here, my job is to isolate this variable. That means get this x to be the only thing on the left side of this inequality here. To begin with, you need to get rid of the constant first. It says -4, so the opposite of -4 is to add 4. So we're going to add 4 to both sides. The 4's cancel. I'm left with 5x is greater than or equal to 15. Now this means 5 times x. So the opposite operation would be to divide. So I'm going to divide both sides by 5. 5 divided by 5 is 1. So x is greater than or equal to 15 divided by 5, which is 3. Now this means it's inclusive. So I'm going to come over here and put a closed circle on the 3. And I need to shade to the right of the 3 since it's going to be numbers that are bigger than 3. 3 would work. I could say 5 times 3 is 15 minus 4 is actually equal to 11, so that would work. But you could also test 4. 5 times 4 is 20. 20 minus 4 is 16. 16 is greater than 11. All right, let's go over here and try this one now. For this problem, I want to first get rid of the plus 4, so let's subtract 4 from both sides. 4's cancel. I'm left with b over -3 is less than 13 minus 4, which is 9. Now, as I said earlier in a different video, b divided by -3, if you want to get rid of a denominator, multiply by it. I also mentioned that if you ever multiply or divide by negative, you have to turn the inequality around, so we can't forget that. The -3 over the -3 cancels, and b is isolated. The inequality has to turn direction, and I have 9 times -3, which is -27. b is greater than -27. Now, it's not including -27, so it's got to be an open circle. And the numbers bigger or greater than -27 would be to the right. So you can take a number to the right of this and test it into the problem to see if it works. And it's smart to use numbers that 3 goes into, so you don't have to end up practicing with some kind of fraction.